Hello friends, welcome to Clarify and Decode. So today let's look at a systematic approach for performance improvement based on the code. Like we are talking low level code performance improvement. We are actually improving the code. How to find it? What are the steps you can think of? So here you actually know or have a fair sense which module or classes is causing the issue. Maybe like a dashboard which is not loading as per your expectation. So what can be done about it? So the first one is code review. Just manually look at your codes. Okay, whatever you know in terms of best practices that should be applied. Simple things like, is there any excessive loop? Okay, are you using the right data structures? Just look at your code. Did it require async calls and you didn't provide it? How many objects you are creating? Are you disposing database connections or the contexts? Are you doing the string concatenations fair enough? Or you can do a peer review or just reach to your mentor or senior just to have what do you find that is not correct in this code. So we don't need to go in all advanced level of debugging, and with our own naked eyes or with somebody's experience we can just improve it. Fine. So this is code review. Suppose we didn't get anything or the code are very big or we need to think about a lot of classes and methods, then it can be a bit tricky, right? So after this, the next step would be we will utilize something called the static code analysis or the analyzers or the refactors. Okay, so here many people would have heard these tools like resharper, sonarq. Okay, this is specific more to .NET. This is for Java and .NET both. sonarq. Okay, other tools as well. So what are the major advantages if we go with static code analysis? You can look at other tools as well from the Java world. This is a bit outdated, but fair enough. With static code analysis, we would get a precision because the tool are like made for this specific purpose, right? So it cannot lie. Whatever it is saying, 99% it is correct. It is giving you a precision. Okay, improve on this loop, refactor it. Okay, and if it is giving a comprehensive coverage, it's not just looking at one method, right? Whole code base it is checking for you, all your classes, modules, DLLs, jars, everything they can cover, and they can cover quite quickly. It's not manual, right? It will look and think and understand, and it will give you detailed metrics what it finds about. Okay, and it will also give you refactoring suggestions. Okay, with manual code you found, okay, this loop is not optimized, what to do, but here you are getting the solutions itself or the suggestions at least, right? So it's kind of very advantageous and also can say best practice to at least have one static code analyzer in your IDE, whichever IDE you are using for Java, .NET, but this helps. Okay, fine. Suppose this also didn't help you because the code is not running, right? You don't know how many users are concurrently logging or attacking your system, what kind of database calls are going through, what API calls, what network calls, right? We don't know what is happening when the code is executing. So the static code analyzer will not give you all the context. Okay, what will you do next to find the actual line of code which is causing the issue or the function that needs to be optimized? Let's look further. I would say instrumentation tools for some organizations or for some context it would not be the third, but I am placing it in third if you already have it running in your environment, in your customers environment, local environment, whatever. If you have it, use it. It's really helpful. Major players: Datadog, Dynatrace, New Relic. If it is in Azure world, it's very easy to utilize application insights, app dynamics, Kubernetes world or other context, Prometheus, Grafana. Okay. Here, what are the major advantages? Let's look at. First is real-time monitoring. Okay, you already have the data. It's not like, okay, I have the performance issue, now I need to configure something and then check. It's already there, right? You just need to look up, or even you can get some automated messages if there are performance issues. Some tools are even powerful to predict based on the trends. Okay, so you will already know, and it's already live. You don't need to think, okay, now in a performance situation, do I need to something else? Fine. And it is very good for large systems, for enterprises, when we have like hundred of microservices and many different technologies interacting with each other. We don't know which flow is going where, the distributed traces. How do we know them? Okay. So they will help you. Like if you have 10 APIs, one of the API method is not responding well or is causing the overall delay in performance, they will pinpoint to the exact API, even to the exact hotspots of the methods, right till the code level, what kind of calls at the framework level is causing the issue or any other insights. So this is really helpful in large systems. Prod systems generally will have it on a grid scale, the monitoring in prod systems, pre systems, right? So it's already live and you have the monitoring. You just have to study and utilize that. And it is accurate, right? Because it's makes a decision based on the previous response as well. So the previous response for an API was 5 milliseconds. Now it has gone to 7.5 milliseconds. So there is a percentage increase. So it would alert as a slow response. Okay, it would give it in your dashboard also and in all your notifications, or the way how you configure it. So it's data driven. Okay, and as I said, it can also predict also when it sees like the issue can happen. Okay, in terms of either like the API was hosted on a server and sees this CPU as growing, okay, or at a particular time, a particular week event it sees it is reaching to its brink, it can predict and it can alarm you. So that's the magic of APM tools. Fine. But many organizations would not have the APM tools. Some are a bit costly also, some are like low priced, and not every organization does have the APM tools with them. Okay, but if it is a big organization, definitely they would have some kind of monitoring either at an advanced level, low level, or they would be thinking about it, the observability part. Fine, suppose you don't have it, or it is a slow, not slow, system which is just evolving, right? a kind of startup or an old enterprise who doesn't have it. So what else you can think of? So just a recap, we did naked eye code analysis, we did static analysis. So this is what? This is instrumentation, or you can say runtime analysis also. Okay, fine. One important thing which many people miss out is the traditional logs or advanced logs. Logging. You definitely will have logging at least. Okay, that we expect. So from there we can see what are the log running tasks or loops. If we have some basic level of debugging that is done rightly, like start of a big task, end of a big task, so we'll know, right, which is the long running tasks. Fine. If it is in dev system, what you can do, you can just write a simple line of starting a watch, a time, date time, and then you will say stop the execution or stop the stopwatch when the method is returned. Okay, return x and then just log level. So we'll understand in local context also just with the stopwatch. Okay, it's taking 15 milliseconds. Okay, and okay, this is user id which has lesser data, it's taking 15 milliseconds. Let me see what happens when I utilize the endpoint with a user id which has like a lot of data, a lot of bookings, what happens. So we can understand the duration it is taking just with logging itself. And also it will have historical data also, right? Suppose we say in the night it is not working fine, so we will need to just go at that time, a duration of time, and see what happened for which particular user. If we have some kinds of loggings in terms of start, end, or loop execution times. Okay, sometimes in production we also do a little more verbose level for methods we think it's not working fine. We can have some advanced, not advanced, but more verbose logging there, right? And we have more advanced logging tools now as of, in terms of like Serilog, Log4j. It was recently, you would have heard it in the news for vulnerabilities, but fine, you get the essence. And log, elk, all those kinds of stuff. Just a minute. Okay, the next is profiling. So even with logs, if we don't get it, then we need to dig deeper. We need to think of profiling. Profiling your application, the processes, okay, in terms of like CPU, threads, memory. Okay. So for this profiling, I've started another series which has more in detailed things, what is profiling and how it should be done, different types of profiling. And also the first one, code analysis, I said, right, naked. So I have also a video for best practices, so you can get an idea from that, a bigger detailed observation for best practices when we write the code. And for profiling also there is a separate video in this performance series, but let's have a quick look here. So like suppose the CPU is spiking up in the dev server or whichever area we look at it. So think why the CPU is spiking. It has very limited metrics which are very important, and you need to know, if I have this metrics, if this is increasing, what is happening. Okay, example, CPU utilization is increasing. So is it like garbage collection is running a lot, which is powered by the CPU, or the CPU effort is taking there? So we need to think why garbage collection is running more, or am I spinning a lot of objects, something like this. Also with profilers we will get CPU time, like which execution in terms of even at the function level or at the thread level is taking more time. Okay, so we'll get which particular function the CPU time is more. Okay, are there many context switches? Does the CPU need to context switch a lot? Okay, is there a lot of CPU wait time? I'm not explaining in details as the video would go long. There's a separate topic for it, but I'm saying profile. Quick touch up on threads as well. Are we spinning too many threads? Is the multi-threading not done correctly? There is a lot of locking. Are there synchronization issues between the threads? Are some threads waiting and ending up in deadlocks? What kind of code can cause deadlocks? Look at the code methods where there is multi-threading. Those kind of things are done and it's not properly optimized or written to prevent the deadlocks. Fine. Memory, look at the heap size. Is it lot? Okay, C for large object heaps. Okay, this 5% is remaining. I hope I would close this soon. Okay, fine. C in terms of memory, which objects are taking a lot of space. Okay, so we'll know, okay, class xyz employee class, it is having a lot of instance and it is taking a lot of space. So why there are so many instances? So we'll get an idea which classes to focus on, which namespace, which jars, okay, which framework classes itself. Okay, are there a lot of generation survivors which are never getting cleaned up? Fine, you get the idea. There can be other profilers as well. We can profile for network, disk, if it is database related, performance issue, database profiling, query profiling, a lot of things. So for each performance related concept we can actually profile it and get some idea. Fine, suppose nothing is working out, then we have to go right at the bottom. We need to identify classes, methods, or areas which we think is causing the issue, and we need to benchmark those. Okay, so it's called benchmarking. It's like I will just run the present code and it says it's taking 5 seconds in this load, in this CPU, in this bare metal, or in this infra. I improve the code based on my knowledge or other insights and just see how speed it is turning up. Okay, so that's benchmarking. So here it is focused on a method, code blocks, or a functionality, you can say. We cannot like improve, write code and improve all the methods and just see how it goes, right? We have to go step by step. It's not like I write, and also in one method we have to think logically. It's not like make 5 code improvements in the same methods and do benchmark. One may be improving the speed, one may be degrading the speed, so we'll never know what is happening and which is the right way. So do some small improvements and see, run the tests again. Okay, yeah, so what I was saying is it is comparing between implementations and we are actually optimizing this. X code is giving this, x plus y code is giving this, x plus y minus z is giving this. It can also help us in capacity planning. Okay, like a particular method we fire and we give it a load in terms of like users or data, and we try to see how much performant it is, like, and if we suddenly increase the load to 10x times, does it slow down? Does it slow down to a level which is not acceptable to business or users? Then we need to do the capacity planning based on how powerful the code is. Fine. Hardware infra evaluation. Why? Because we can run the code or solution in different hardwares or infra setups. Okay, like maybe in a high powered CPU, okay, or a CPU which is equivalent to that in the prod, or a different CPU architecture, whatever. But the benchmark will give different data in different environments, and we can have a graph also. We can collect the data and analyze it. Fine. And suppose we change some code, and it is very important code, like payment should really go in 5 seconds, and there was some other changes in upflow, downflow, or within the method itself. We cannot pass it, right? There can be other ways like performance testing of the whole application flows, etc. But if that piece of code is very important, you have to have the benchmarking of that, right? So regression testing, or if it is a new code which is very important, we cannot go directly into the prod, so have it benchmark. So as I said, before deployments it's helpful, before prod deployments, before any good live events. Fine. So let's recap sequentially. First is check bare eyes. Second is already in the IDE, you will have static code analysis. Third is runtime analysis if you have some APM tools, right? Fourth is logging. You can utilize logging. Fifth is profiling. And the last one is benchmarking. There may be other concepts as well, because software is like all contextual, and I would say it's an art also, right? How we improve, different people have different scenarios, but these are the backbone, the skeleton on which we can improve the performance, like a systematic path. Let's go on this way. Fine. But suppose we didn't get anything, right? So there can be two reasons. Either we are missing something from these points, or maybe the code based on the infra, the data we have, right? It has reached its peak power, like it cannot perform more than that, right? Because you cannot just go into improvement beyond a certain level, because we are utilizing, if it's like C sharp, Java, and other things, whatever the framework is giving us, that only we can write, right? We have optimized it till our knowledge, or till we cannot like keep ending this, right, for a long time, that no, I will write the most performant code in the world, but this piece of code I will keep on improving. So it's contextual, based on timelines, on business. Fine. But if these are not helping in few goes, think of other methods apart from the code. Okay, other performance concepts. This also have made a separate video, like for API what can be done end to end. For websites I would be making one. In general, it's like, oh, I forgot to tell some names for the benchmarking. Most popular for .NET is benchmark.net. It's just like DLL. You will import it and just run it, giving the reference to the method we want it, right? And it will give something like a graph here, mean response time, or like latency, other things. Just go in Google, just go in images after writing benchmark.net, you will understand. For Java, it is Java microbenching harness. Many people would not have heard of these, but if you say these things in interviews, or also you can employ in your day-to-day learnings or in project improvements, it would really open up your mind how things are working up. So it's I would say very advantageous to go one level up after writing the code, and you will enjoy it, right? Fine. So what I was saying is, if nothing is helping from these topics, what you can do is improve beyond code, like do some caching. You can do horizontal, vertical scaling, sharding, partitioning your databases, move it into everything like containerized world, KATS, okay, have some load balancers, those kind of things, CDNs, any other performance techniques that you can think of. Okay, I hope you enjoyed today's session, and this is a part of the series for software performance concept. It's like I'm making it generalized for all languages. It's not specific to Java, .NET, PHP, Go, whatever. These concepts remain the same. Maybe the tooling can differ, right? Maybe the imports names can differ, but the concept remains the same. Fine, friends. If you're liking my series, please do subscribe. I want to make more videos as time permits, so I don't want you to miss out whenever I post it, because it's not very regular when I would be making the next videos, and maybe you are not aware when the next video is coming. So please do subscribe and have the follow up with the notifications. I am hopeful that these would be helpful for your day-to-day work, interview processes, for your learnings, and you would enjoy my topics. Thank you. Keep stay tuned. And just the last thing, I have made a poll on what topics should I explain more or should prioritize. Just check it and please do vote. It really helps me a lot. The topics that I had posted are this one, software performance. The second one I had given is for Kubernetes concepts. The third one I had given for system design, and the last one is for cloud concepts. Okay, like demystifying it, what is everything related to cloud, what are the functionalities, how it is good, how it can behave bad, all those contexts. Fine. My objective is to go in a sequential way for each topics and cover end to end. So that's my some of my videos. When I explain like this, it goes a bit long, but I just really want, like, when people are starting a topic, they should understand it end to end, and they should gel up what is happening for that piece of information, and they don't need to look up anything more, or it is till a sufficient level for that topic. And that's why I want to keep the videos till 30 minutes. Sometimes I explain it quickly in like 5 minutes if it is helpful for an overview, or maybe 15 minutes. Okay, fine, it's almost 30 minutes and my battery didn't help us also, but I would like to thank you to have some patience and just listen to it, share it, so that other people also do benefit. And what I'm trying is to make videos that are not very frequently available. They are like in courses, very pricey courses in Udemy, performance improvements. It's not a like topic which is, I would say, easily available on YouTube or in detail or in a good quality. So I'm trying to spread this and help people. Please do support me. Thank you.